Hello everyone, and welcome to your video on solving 3x3 determinants. It's a little uglier than its 2x2 friend, but it is still possible. Before we get into this, I want to make sure that you understand the 2x2 determinant. So in this case, we would multiply 2 times 4 to make 8. We would then minus 9 times 6, which is 54. So this determinant reduces down into negative 46 because that's what 8 minus 54 is. All right, now in a 3x3 determinant, things are not quite that neat because we have too many terms, right? We only know how to solve a 2x2 determinant. So there is a method for us to do this, and it is called expanding by minors. It is not super important that you remember this, except that, you see it in math. And so you should know what they're talking about. They're talking about the method by which we solve a 3x3 determinant, and that is called expanding by minors. Now, before we get started, I want to show you this chart. Okay, see if you could follow along at home. We have a plus, we have a minus, we have a plus. Then we have a minus, and we have a plus, and we have a minus. Then we have a plus, and a minus, and a plus. So we have this alternating grid that goes in both directions. You will need that in order to expand by minors. So I'm just going to put that here, and we will look at that as we solve this problem. Okay, so expanding by minors. The first thing that we want to do is we want to pick a column or row. It does not matter at all which one you pick. It is entirely up to you, and because I like to start at the beginning, I'm just going to pick that beginning column. That's going to be what I work with first. So you will notice that this 3 corresponds with this plus sign, and then this 4 corresponds with this minus sign, and this 8 corresponds with this plus sign. So that's important because here's what we're going to do. We're going to say that this matrix, this determinant, can be broken down like this. We put in a plus sign, and then we put in our 3, and then we multiply that 3 by the minor. Now you're saying, what? We multiplied the 3 by the what? This is what I want you to imagine. I want you to imagine that someone comes and blocks out everything that goes down from the 3 and blocks out everything that goes across from the 3. See that little tiny 2x2 determinant you have left? That's what we write here. 3, 7, 1, negative 2, indeterminate. Okay, now, just stick with me. Now, we move to number 4. We need a minus sign here before the number 4, because the 4 goes with the minus sign, so minus. And then I do a 4, and then I'm going to multiply this 4 by the minor. What is the minor, you say? Well, we're going to cut off the column that the 4 is in, and we're going to cut off the row that the 4 is in. If I can get my pen not to move. There we go. And what is left is hard to read, but that is our 2x2 determinant. So that will be 2, 5, 1, negative 2. Okay. Then we move to 8. 8 gets a plus sign. Then we write 8, and we are going to multiply 8 by its minor. So we will take off the row with the 8, and we will take off the column with the 8, and that, what's left, is the minor of 8. So 2, 5, 3, and 7. All right. So now that we've done that, we can start solving this. So we can say plus 3 times negative 6 minus 7, right? 3 times negative 2 is negative 6. 1 times 7 is 7, so I'll minus 7. Minus 4 times negative 4 minus 5, right? Right. plus 8 times 14 minus 15. Sweet. All right, so let's simplify again. So that's going to be positive 3. So 3 times negative 13 minus 4 times negative 9 plus 8 times negative 1. All right, simplifying again, we have negative 39 minus negative 36, that's the same thing as plus a positive 36, plus a negative 8. And when you slam that thing into your calculator, you get that this determinant equals negative 11. Got it? Of course, you only need to practice it by doing it, I don't know, maybe 15 more times. Okay, but we're not going to do all 15 in this video, but we are going to do one more. So let's do this. I'm going to make the exact same matrix here. So we have 3, 4, 8 going down, 2, 3, 1 going down, 5, 7, negative 2 going down. But this time, instead of picking this first column right here, instead of doing that, let's just pick this second row. Okay? All right, and before we get started, let's just remember our pattern. Okay, good. All right, so now we're going to work with this. So we're going to, again, expand by minors. So I'm going to start with the number 4. Number 4 corresponds to this negative sign right here. So I will do a negative 4 times its minor. So if you can imagine this and this disappearing, what's left? That would be 2, 5, oops, better give myself a little bit more space, 1 and negative 2. All right, and then the 3 corresponds with a plus, so I'll do plus 3 times its minor. So we're going to cross off this, and we're going to cross off that center column. So we have left 3, 5, 8, and negative 2. 3, 5, 8, and negative 2. And then we're going to do 7, and 7 corresponds with a minus sign, so I'll do a minus sign. And then I'll do 7 times its minor. So again, the blue row is going to disappear, and then this is going to disappear. So we're left with 3, 2, 8, and 1. 3, 2, 8, and 1. All right, now we get to simplify. So this will be negative 4, right, because this is negative 1 times 4, times negative 4 minus 5, right? 2 times negative 2 is negative 4, minus 1 times 5 is 5, plus 3 times, what is this, negative 6 minus 40, minus 7 times 3 minus 16. So simplifying, that is negative 4 times negative 9 plus 3 times negative 46 minus 7 times negative 13. All right, so this is going to be positive 36 plus a negative 138 minus a negative 91, which really is going to be plus a positive 91. And so you put that in your calculator, and what do you get? You get negative 11. So you get the exact same answer that you got when you picked this column as when you pick this row. That's why I said it doesn't matter which row or which column you get, you pick. You get the same answers, whichever one. That being said, however, you kind of want to pick the numbers that you like the best. And our favorite number in the world of 3x3 determinants is the number 0. Let me show you this. Let's say we had 5, 0, 7, negative 3, 0, 8, and 14, 0, 9. Okay, so when I do this, I'm going to pick this column of zeros here because that's awesome. All right, so again, you have to remember your little chart. You can't just go willy-nilly picking whatever you want, okay? So this 0 corresponds to a negative. So I start off with -0 times its minor, which is you cross off this row and you cross off this column. So you get -3, 8, 14, 9. And then we do a plus 0 times its minor, which is 5, 7, 14, 9. And then we do minus a 0 times its minor, which is 5, 7, -3, and 8. Okay? You guys following me here? I'm not even going to have to calculate what this is, because whatever it is, I'm multiplying it by 0. So this becomes 0. A -0 if you like, but a 0. This right here becomes 0. This right here becomes 0. My whole answer is 0, and I did it super fast. In fact, if I had wanted to, when I was writing this initially, I could have said -0 times its minor, and who cares what that is, because it's going to be 0 anyway, plus 0 times its minor, and again, we don't care what the minor is because we're multiplying it by 0, minus 0 times its minor. And again, we don't even care. Look I'm not even writing down the numbers. I'm such a rebel. I know that the answer is 0. So when possible, pick the column that has the most zeros in it, because that will shorten your work significantly.